Hi everyone. I'll be doing this question and it's from a past paper. It's from Mechanics 2, 2023, October, November. And as you can see, it's a collision question, but in this case, it's not two particles. You have one particle and an impulse, right? So the mass of the particle is 0.25. Initially, it's given an impulse of 1. Sorry, not 1, it's I. Yeah, I. Of I at an angle of 60 degrees, and then immediately after receiving the impulse, the speed of q is 12 at an angle of alpha. Okay, so I'll just draw a diagram. So let's see, the particle is here, it's traveling at 8 meters per second, then receives an impulse of I at 60 degrees, and then immediately after the impulse, leaves with a speed of 12 meters per second at an angle of alpha. Alpha, it looks like A, but usually we call it alpha. So, yeah, this is your question. So in this case, we have to consider impulses before collision and impulses after the collision. Okay, so these have to be equal. That's your first case, and your other one is vertical impulses should be the same. Okay, so these are two cases, so let's focus on the first one. So impulses before collision and impulses after collision. So impulses before collision, it's going to be 8 into 0.25, which is the mass of the particle into its speed. Impulse is mass into velocity, plus I, which is the impulse, it's already given, cos 60, because we have to resolve it, right, along the x-axis. And sorry, I forgot to mention, this has to be horizontal, right? This is for horizontal and that's for vertical. This is for vertical, horizontal. So I cos 60 equals to 12 cos alpha into 0.25. Now you found your first equation. And then your second equation, vertical impulses. I sine 60 equals to 12 sine alpha into 0.25. So let's simplify your first and second equation. 8 into 0.25 is 2, cos 60 is half, equals to 2 into 0.25 is 3 cos alpha. And your other one is sine 60 to root 3 over 2, I equals to 3 sine alpha. This is your second equation. Okay. So I equals, I'm rewriting the second one, I equals 6 over root 3 sine alpha. Okay, so this is your third, and I just wrote it as the third equation. So what you do is you put your third equation into the first equation. So then that is 2 plus, so instead of I, we put in this for the first equation, right? So 2 plus half into I. So 6 3 sine alpha equals to 3 cos alpha. So 2 plus 3 sine alpha equals to 3 cos alpha. So let's take this onto this side. So that's 3 cos alpha minus 3 root 3 sine alpha equals to 2. Okay, now see, solving this trigonometric equation is a bit, it's not hard. I don't say it's hard, but it's a bit tricky, right? Because it's not in a quadratic format, it's not in any format, right? It's just cos alpha and sine alpha. So what we can do for that is, ignore the 2 for now. So you have to know, let's say we have alpha, okay? So cos alpha plus beta equals cos alpha cos beta minus sine alpha, sine beta. So this is a rule. Any two angles for cos, any addition of two angles equals to that. So cos alpha, we don't know, right? But this angle, beta, we should find a value for beta. So we are writing this in this format. So we can find the angle straight away. So what you do is, you write cos alpha plus beta equals to 3 cos alpha minus 3 root 3 sine alpha. And then you write cos alpha cos beta minus sine alpha. Sine beta equals 3 cos alpha minus 3 root 3 sine alpha. Okay? And then you consider this with this and this with this. Okay? So then cos alpha cos beta equals to 3 cos alpha. And sine alpha sine beta, you can see there's a minus in front of each, so you don't have to worry about that. Goes to 3 root 3 sine alpha, right? So you can cancel off cos alpha, cancel off sine alpha. So you have two separate equations where you can find beta, right? There's one more thing I forgot to mention to you guys. So there is another constant in front. I just remembered it now. You can call it R. So we'll put R over here. Yeah, there should be another constant in front because that was you might have this in your formula sheet. I'm just doing it with memory, so I got it in now. So there is another constant in front. So I just forgot to mention it to you guys. So now you have R cos beta equals 3. R sine beta equals 3 over root 3. Now you can divide these two, right? Let's put equation 5 over 4. So this gives you sine beta over tan beta is tan beta. So sine beta over cos beta is tan beta. Yes. So that gives you 3 root 3 divided by 3. So this is 1 over root 3. So tan beta is 1 over root 3. So tan inverse root 3 is beta equals 30. So you found beta. So now we can find R cos 30 equals to, you can take either equation. I'm just taking the fourth one because we don't have to deal with the root. So cos 30 is root 3 over 2. So R equals 3 into 2 over root 3, giving you 6 over root 3. Okay, let me just double check. So 30. Yep. Well, good. So now you can write, instead of writing this, you can write 6 over root 3 cos alpha plus 30 gives you 2. So now you can find the value for alpha, right? So that's root 3 over 3. So cos inverse root 3 over 3 is Yeah, I don't know. Something's wrong with my calculator. So now I'm getting a cos inverse root 3 over 3. So alpha plus 30 equals 54.7356. You can just write it like that. And let me just check the radian then. Yeah, that's a decimal place too. So we can just write it down like this. So alpha equals 54.7356 minus 30, which is 24.7356. So we found our angle alpha. Now, we know I equals 6 root 3, 6 over root 3, 6 over root 3 sine alpha, right? So you can just sub in your value for alpha. So this should give you 24, 6, 1.449. So I equals 1.45. Yeah, you can say 1.45 Newton seconds. That is your answer. I hope you all understood. That wasn't hard, right? You guys can definitely understand it. If you guys have any doubts, just drop them in the comment sections. If you guys have like any other questions apart from these lessons, like any other questions in it can be any lesson, I can help you all. Just drop them in the comment section. I hope you all understood. And if you like this video, leave a like and subscribe. And yep, that's everything for this question. And thank you. Have a great day.